Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P04F1 indicates an issue within the evaporative emission control system, specifically noting EVAP system low purge flow detected. This issue involves the system that captures and recycles fuel vapors from the fuel tank. The components involved in this system include the EVAP canister, purge valve, vent shut valve, and the fuel tank pressure FTP sensor. The function of the EVAP system is to prevent fuel vapors from escaping into the atmosphere, which can contribute to air pollution. When the DTC is triggered, it signifies that the flow of vapors from the EVAP system is lower than expected, potentially indicating blockages or malfunctioning parts in the system. Correctly diagnosing and addressing this DTC is essential to ensure optimal vehicle performance and adherence to emissions regulations. The DTC P04F1 pertains to the EVAP system, which is designed to capture and store fuel vapors. Key components include the EVAP canister, which holds the vapors, the purge valve, which controls vapor flow into the intake manifold, the vent shut valve, preventing external air from entering the canister, and the fuel tank pressure FTP sensor, which monitors pressure within the system. These components are typically located close to the fuel tank and under the vehicle's hood. The proper functioning of these parts is critical in minimizing emissions, and any low purge flow indicated by this DTC could suggest that either a blockage exists within the purge line or that one of the components is failing. Recognizing the roles and locations of these components helps in understanding why the DTC may have been triggered. Several factors can contribute to the triggering of DTC P04F1. First, poor electrical connections can create effective interruptions in the communication between components such as the FTP sensor and the engine control module, ECM. Any issues with loose or corroded terminals may disrupt function. Second, the EVAP canister purge line can be blocked or damaged, often due to contaminants or physical wear, which can restrict vapor flow. Third, a malfunctioning purge valve may not open or close correctly, inhibiting or allowing inappropriate flow of vapors. The presence of any of these issues can adversely affect the performance of the EVAP system, triggering the low purge flow detection. When the DTC P04F1 is present, drivers may observe several symptoms that could indicate an underlying problem with the EVAP system. One common symptom is an illuminated check engine light on the dashboard, which signals that there's a fault requiring attention. Additionally, there may be noticeable fuel vapors escaping from the vehicle, particularly during refueling or when the engine is off. Another potential symptom is poor fuel efficiency, as the vehicle may struggle to maintain optimal performance due to the EVAP system malfunction. Awareness of these symptoms can aid in early detection, allowing for timely repairs that can keep the vehicle running efficiently. Step 1 in troubleshooting DTC P04F1 involves confirming the issue by operating the vehicle's systems. Start by turning the ignition to the on mode without starting the engine. This prepares the vehicle's onboard diagnostic system. Next, use the Honda Diagnostic System HDS to clear the current DTC, which resets the fault codes stored in the ECM. Once cleared, navigate to the inspection menu. Select the EVAP test option, and then proceed to perform the function test. Monitoring the results at this stage is crucial. If the test indicates the system is okay, this may suggest an intermittent fault, potentially stemming from connection issues. However, if the failure reproduces, it is essential to proceed to subsequent troubleshooting steps for further diagnosis. In troubleshooting step 2, the focus is on visually inspecting the EVAP canister purge line. First, turn the vehicle off completely to ensure safety during inspection. The purge line is located between the intake manifold and the EVAP canister, and a close examination should be made for any signs of poor connections, damage, or blockages. This step is critical because if the line is compromised, it can prevent proper vapor flow, leading to lower than necessary purge flow rates. If the line is found to be in good condition, the technician can confidently move on to the next step. Conversely, if issues are identified, repairs or reconnections must be made at this point. Step 3 involves assessing the functional integrity of the EVAP canister purge valve and the associated lines. Start by removing the EVAP canister purge valve while keeping the connector and vacuum hose attached. Next, disconnect the vacuum hose from the valve and then the hose from the EVAP canister, ensuring that you maintain organized connections. This creates a space to connect a T-fitting, a vacuum gauge, and the vacuum pump to the EVAP canister purge line. Applying approximately 2 kilopascals, 0.6 inch right, to the hose allows for testing whether the hose can maintain vacuum. If the hose cannot hold vacuum, it likely indicates a blockage. If it holds, further inspections are required to identify other areas of failure. In troubleshooting step 4, the goal is to check the functionality of the EVAP canister purge valve itself. The purge valve must be carefully inspected for any signs of wear, damage, or internal faults that could prevent it from functioning properly. If found to be defective, it will not open as designed, restricting vapor flow and triggering the P04F1 code. If the valve is confirmed to be in working order, the technician can proceed to step 5. However, if issues are detected, it is necessary to replace the EVAP canister purge valve to restore the normal operation of the EVAP system and clear the DTC. Step 5 requires connecting the vacuum pump to purge tube A for testing. Begin by connecting the designated vacuum pump and gauge to this tube. Then, start the engine and let it idle, which sets the conditions necessary for testing vacuum levels. At this point, observe whether vacuum is present in the tubing. A proper vacuum reading indicates that the purge tube is functioning correctly, while no vacuum would imply a blockage along the path between the intake manifold and the EVAP canister purge valve. It is essential to confirm that there are no restrictions in this tube, which could also contribute to the low purge flow detected by the DTC. In troubleshooting step 6, the performance of the fuel tank pressure FTP sensor is assessed. Start by turning the vehicle to the off mode and removing the FTP sensor, while ensuring the connector stays intact. A T-fitting should be connected to the sensor vacuum hose along with a vacuum gauge. Once the system is set up, turn the vehicle to the on mode and record the FTP sensor readings using the HDS. It is vital to apply a controlled vacuum of about 1.3 kilopascals, 0.4 inches per second, carefully. Exceeding this may damage the sensor. Following this, check the data from the HDS once again. A change in the reading indicates a functioning sensor, while no change would mean the FTP sensor requires replacement. The final troubleshooting step examines the EVAP canister purge line again. Start by reconnecting the EVAP canister purge line to the canister and reinstalling the FTP sensor. After this, the next task is to disconnect the vacuum hose from the EVAP canister purge valve for testing. The T-fitting, vacuum gauge, and vacuum pump should be connected to this hose. By slowly applying about 2 kilopascals or 0.6 inch hay of vacuum, it becomes critical to observe if the hose can maintain this vacuum. Successfully holding vacuum suggests that there is no blockage at the canister purge line port. Conversely, if the hose fails to hold vacuum, It indicates that the EVAP canister vent shut valve may need replacement, as it could be malfunctioning and causing the low purge flow condition. After completing the necessary repairs and replacing any faulty components, it is crucial to verify the integrity of the repairs performed. Begin by rechecking for any DTCs using the HDS. Clearing any previously logged codes should also be repeated. Following this, test the overall operation of the EVAP system under various conditions to ensure everything functions correctly. It is important to monitor for new DTCs appearing, as this can provide feedback on the effectiveness of the repairs. Performing these final checks allows technicians to confirm that the problem has been resolved, ensuring the vehicle is compliant with emission standards and maintains optimum performance. Preventive maintenance is essential to avoid encountering the P04F1 code in the future. Regular inspections of the EVAP components, such as the canister, valves, and hoses, can help identify wear and damage before they become significant issues. It is also crucial to use high-quality fuel, which can reduce contaminants that may block the EVAP lines. Additionally, any signs of leaks or irregularities should be addressed immediately. Timely maintenance can significantly prolong the lifespan of the EVAP system while ensuring adherence to emission regulations. By implementing these preventive measures, vehicle owners can minimize inconveniences and maintain efficient vehicle operation. In summary, DTC P04F1 indicates a malfunction in the EVAP system with low purge flow detected. Understanding the components and their functions is key to diagnosing the problem accurately. A systematic troubleshooting process, including the 7 detailed steps, provides a comprehensive method for identifying and rectifying the underlying issues. This includes verifying component functionality, checking for blockages, and ensuring proper communication within the system. Implementing preventive measures in the maintenance of the EVAP system can help avoid future issues and ensure compliance with emission standards. Awareness and proactive action concerning these systems not only enhance vehicle efficiency, but also contribute to environmental sustainability. Please like and subscribe to the channel. See you next time.